Alright, so let's say they give you this diagram here where an arbitrary force acts on mass to give it an initial velocity of 2 meters per second, and they ask you, what is the force of friction on the object? Could you answer? If not, continue watching this video. So to answer this question, we need Newton's second law, which is the summation of the forces is equal to mass times acceleration. If we look at our diagram, we can identify all the forces, which we have the weight force, which is the force due to gravity, and then we're going to have the normal force, which is the force due to the mass being on the surface, and then we're going to have the friction force due to the velocity of the mass on the surface. And we can identify our coordinate system, the x and y. If we break down our summation into components, we have the sum of the forces in the y is equal to mass times acceleration in the y. If we look at our diagram here, the two forces in the y direction are the normal and the weight, and the weight's in the negative y direction, so it's going to be n minus w. The normal force and the weight force are going to be equal to the same thing, just equal to mass times gravity. And so if we plug this in, we end up getting that acceleration to y equal to 0, which makes sense because the mass is not accelerating in the y direction. Now we can look at the sum of the forces in the x direction. So if we use our summation in the x direction equation, we can note that the only force is the friction force, and it's in the negative x direction, so it's going to be negative. And if we plug in our known mass, we can note that we have two unknowns in this situation, the friction and the acceleration. So the first thing we need to do to find the acceleration is use the kinematic equation below. And if we plug in our known values, we get this expression here, evaluate each term, and then isolate for acceleration by bringing 4 meters squared second squared to the other side. Isolate for ax by multiplying both sides by 1 over negative 10 meters. Divide the units in the amplitudes, and we get this for the final answer. This is the acceleration of the object to the force applied to cause it to have velocity VL equals 2 meters per second. Apply this back to our equations, plug in our values, we get this expression here, and we can evaluate to get the friction force equal to negative 0.18 kilograms times meters per second squared. Just note that kilograms times meters per second squared is equal to newtons, so we can just replace it by newtons, and we get this for the final answer. This is going to be the force of friction felt by the object throughout its motion. Draw a diagram here. We have the acceleration equal to 0.4 meters per second squared. And then we have our friction force equal to negative 0.18 newtons. So that's going to be applied onto the object while it's in motion. That's what causes it to eventually reach velocity equal to 0.